In this example, we're looking at a capital budgeting decision for a ski resort. This is an example of a constrained capital budgeting decision because this ski resort needs to make two investments, but they only have enough cash right now to afford one of them. So they have to make a decision about which one they're going to purchase now and push the other one off. So they have two problems. They have had problems with low annual snowfalls and long lift lines. So they're trying to decide whether they want artificial snow machine or a new chairlift. They can only afford to do one. So we're going to look at the two decisions together. We have information here about our decisions, and then we also have some information that neither investment has a salvage value. The only difference between the income and the cash flows, depreciation expense, and they have a 20% required return. So what we're going to do is we're going to look at what is the incremental income. We're given revenues and expenses. And then we need to add back the depreciation expense to get the estimated annual cash flows. So the depreciation expense for the snowmaking equipment, we have no salvage value. So straight line depreciation is historical cost minus salvage value divided by useful life. So we just take the cost of $125,000 divided by the 20-year useful life. For the chairlift, that cost is $180,000 and it has a 36-year useful life. We add back depreciation expense and that gives us our estimated annual cash flows. So we come down here and we look at the different proposals. So the first one is, what is the payback period? So you remember the payback period is the investment divided by cash flow. So for the snow machine, we have 125,000 divided by our 31,250. And for the ski lift, we have 180,000 divided by our 40,000 cash flows. So the payback for the snow machine is 4 years and the payback for the ski lift is 4.5 years. The return on average investment, so remember that is net income divided by the average investment. We don't have a salvage value, so we don't have to factor the salvage value on this. So we have the net income divided by the cost divided by 2. This is our net income divided by the cost divided by 2. The net present value of each proposal. So here we just need the net present value factor for an annuity because we don't have any salvage value to that net present value of $1. So we have a 20% required rate of return, and then we have a 20-year period for one and a 36-year period for the other. So the 20-year period, let's find our 20% line, match up with 20 periods. So we need an annuity. 20% at 20 periods is 4.8696. And here we have 36 years. So 20% at 36 years is 4.9929. So for our net present value, we take the cash flows times our factor and then subtract the initial investment. The last two questions are, what financial factors should we consider and which proposal of either do we recommend? So some of the non-financial factors we should consider is which one is kind of the bigger problem right now? Do we have angry customers because of long lines, or are we not getting enough customers because there's not enough snowfall? We also look at what can we control. Well, if we don't have an artificial snowfall machine, then we can't really do anything if the weather doesn't cooperate. However, we have a little bit more control over long lines with or without the chairlift. There's things we can do to help mitigate a long line. So trying to make those decisions about what we would do. So when we see that the payback period is shorter on the snow machine and the return is higher on the snow machine, taken into consideration with the non-financial factors of that we have zero control over the weather, so the snow machine right now looks like our best investment. Our last example is similar to the dinosaur example. So we have a company that's looking at taking on a new product line, and we're going to analyze the information in order to get our cash flows. So we start by making this incremental income statement just like we did last time. So we take 12,000 units times $35 to get our estimated sales. Our variable manufacturing costs are $15 per unit. So we have 12,000 units times $15 per unit. Our fixed manufacturing costs are $60,000 and selling and administrative costs are $50,000. For our depreciation expense, we see that we're going to pay $240,000. There's no salvage value, and we have a 4-year useful life. So we would take 240,000 divided by 6 to get our depreciation expense for 4-year useful life. So we take our sales minus the sum of our expenses to get our income before taxes. We have a 40% tax rate. So our estimated increase in annual income is 42,000. We then add back depreciation expense to get our annual cash flows. And then we have a payback period. So our initial investment is 240,000 with cash flows of 102,000, giving us a payback period of 2.3 years. Our return on average investment is net income divided by the annual investment. Remember, that's historical cost plus salvage value, which is 0, divided by 2. And the net present value, we need the factor for 15% at 4 years, which is 2.855. So the net present value is cash flows times our factor minus the initial investment.